I think we can start. So welcome to this webinar. Thank you for being here. So this webinar will be about this topic of small AI models introduction. So before I start, let me just give you an heads up of how this will go, this webinar. So this will take about 45 to 60 minutes, and this will be recorded, so you can have access to the recording afterwards. We will publish it on YouTube channel. There is a Q&A panel, so you can during this presentation you can make some questions there, and at the end we can discuss a little bit. And yeah, you can also wait until the end to ask some questions. In the end, we'll talk a little bit about these questions that you might have. So yeah, let's keep going. So the agenda for today. So first, we are going to talk briefly about what exactly small AI models are. Then we will talk more specifically about some AI tasks. Then move on to this theme of optimization and deployment of these models, and then we will briefly talk about current trends and future trends, and conclude this topic. Lastly, I'm just going to briefly mention what we do here at Dypsis AI, so our core services, and so you are aware, and it might fit you for your business or not. So yeah, let's get started. So overall, the idea that I want you to have from this webinar is that most enterprises don't really need big models to make use of let's say of AI to solve a lot of the processes that they have. So small models nowadays can have a big impact and solve a lot of these problems. There is also it is also very convenient to use these small models because they are much more focused on narrow tasks, and you have much more control, and for some specific tasks you can even save a lot of money in avoiding some API calls and services that you don't control. So, and it's important also to have this mentality of choosing wisely when to use, let's say, small models, or when to use bigger models. So what exactly are small models? And I think currently it's acceptable to say that a small model is some kind of ML or AI model that is up to, let's say, between 4 to 8 billion parameters. Above that, I think it's hard to call it a small model because it already requires quite a big hardware to run it, even though you can have some, let's say, you can use some techniques to avoid that by quantizing the models. As I was mentioning in the previous slides, the goal of having these small AI models mostly is related to these three main points that I have here below. So you might want to reduce some costs, because you want to avoid some API calls, and you have to have control of the costs as well. For some specific models, it may lead you to faster inference. So you want to reduce some latency of your responses and your processes. You might want to have this control not only about the data that goes into the models, but also control in the sense that you know exactly what model is running, and you have control of the quality of the model, because when you use let's say an external service, if it changes from one day to another, the actual model, and normally they are not that transparent in this sense. So you can have from a day to another, you can have a big a big difference to results on them. So this idea of having control of your own infrastructure is quite important. So you are confident on the results of your processes. Also, another motivation for this the usage of these small AI models is that companies generally have a lot of processes and issues when dealing with data. So then all companies deal with documents and structured documents, and currently there are a lot of small models that can that already can help on a lot of tasks relating to this processing stage, either to ingest them to an ERP or to a CRM, whatever software that you might need in your company or are you already using. So there are a lot of these models, and this is not an extensive list that already provides some value to process these kind of documents. But apart from this, there are a lot of different tasks that are not entirely related to this idea of processing documents, such as speech transcription, sentiment analysis, image classification, time series forecasting. Nowadays, small models already are tackling these issues with some good quality, quite good quality. And so there is no, let's say, excuse to continue using these bigger models that are focused more on general problems. You can start using already this more efficient that can run on, let's say, less powerful hardware and to tackle these tasks. Another motivation for using small AI models is this idea that most companies and have a lot of processes, right, that nowadays are manually done. So because they haven't introduced some digital processes to automate this, and so there are a lot of people that spends a lot of time on these repetitive tasks. When they could be doing some other tasks with value. So the first step that some companies now are making is turning into these LLM APIs to relieve these repetitive tasks, or are just introducing now some digital steps into automation. But there is also this step where you can even optimize a little bit more, which is using these focused models to solve specific tasks in this pipeline of automation or digitalization, let's say. So the thing is that using these small AI models doesn't lead by let's say instantly to less costs, all right? Because nowadays, for example, these LLM APIs, these external services are very price competitive, so the prices are quite low. It doesn't mean it will always be like this, because to gain users that at the time they are very cheap to use, let's say. So you have to think that you have a lot of options when you are considering where to run this AI model. So you have on-prem, which normally has a lot of it has a big investment on the beginning, because you have to buy some kind of hardware to run it, and GPUs are quite expensive, at least to run some bigger models, let's say. Then you can also choose to rent a machine on AWS, Azure, or wherever cloud provider you may think of, and balancing this the cost / benefits. It requires a little bit of strategy and understanding of how these models actually work, and but it's very important to make a wise decision. It's also important to consider that either you might need some control of your data, or control of how the system will behave towards the future. So it's very important to really think about this. So sometimes using, let's say, these services might be cheaper. For the use cases, on-prem might be cheaper, and or even using a cloud provider. So you have to really meditate about this. And let's say there are ways to calculate and to optimize these costs. So but you have really to think about this step. Also, it's important to understand the capabilities of these models in regards to also to their sizing parameters. So currently there is more or less this sweet spot range where above, let's say, 1 billion parameters up to, let's say, 8 billion parameters, we already have some models with quite good quality in the outputs that they produce. However, this is changing drastically, and even up to the future, it is my belief that the capability of these smaller models will improve quite a bit, and we are already seeing this. And I really believe that the future is actually moving towards these smaller models, and also focusing these models on specific tasks. And currently, we already have a plenitude of models that are very specific to tasks, and they already provide great value for those specific tasks. Either being to anonymization, to tasks, tests, either to transcription, either to answering specific questions or text extraction. We have already quite good models that are small, that are very good in these tasks. However, as I was saying in the beginning, we have to understand that for some tasks there are still small models might not yet be there to really solve these problems with confidence. So we have to be smart here and have a strategy to route tasks accordingly to the let's say to the difficulty of the task. And if a task requires a bigger model and we are okay with sending data towards a proprietary model, we might need to still do that in the future. When smaller models are more powerful, we might not need that this routing, let's say. But when we are dealing with let's say a pipeline of tasks, it's really important to diverge to routes for each task a specific model. It might make sense. So and what models architectures are now common on these smaller AI models? Now I'm talking more specifically about the world of LLMs, and but we will also talk about a little bit about more classical machine learning models. So regarding LLMs, let's say, it's common to still see these dense transformer models, of course, with a lot of iterations, considering their initial conceptualization in 2017. Now there are a lot of different changes, like grouped query and a lot of other blocks that have been introduced since then. And for example, this Mamba architecture as well. So this approach of hybrid architecture between transformer models and state space models. And then we have this more classical approach, NLP, let's say, which only uses encoder models. This makes the models be quite smaller. For example, this Glider 2 architecture only uses 200 million parameters. And so it can run on more, let's say, small hardware, and these normally are used for more classification tasks or extraction tasks. Not totally related to small AI models, but in a sense, they are related because this mixture of experts architecture provides, let's say, an efficient inference. So this architecture of mixture of experts basically trades off between RAM space with efficiency. So what happens in this architecture is that even though a model, for example, which might have 30, let's say, billion parameters, in the end it runs like with the speed of 3 billion parameters, which are active, with the intelligence, let's say, of 14 billion parameters. So this is also, let's say, a trend of architecture which is gaining quite a popularity. Then moving a little bit, so you have a more or less a broad view of already open weights or open source models that are currently available to solve some specific tasks. So here I have them categorized for some tasks. So in the area, for example, of vision language. So when you want, for example, to ask questions about an image or a document, for example, Quant3VL2B is a nice model. You also, for example, some days ago, Dypsis launched their new OCR model. So in computer vision, you also have, for example, these two models that are very new, which is YOLO26 and RF Deter. But as you can see, this is quite a big list. You have a lot of already these, let's say, smaller models helping solve very different kind of problems. Concerning ML tasks, of course, more classical models like XGBoost, XGBoost, clustering k-means, etc. So all these kind of models are still used extensively today, and it's important to balance and to understand when to use each. So most of the times companies are dealing with tabular data, so these classical models are still extensively used for that. And this also brings us to this question of when to use these kind of foundational models. So these quite big models that have already been trained on a lot of data, and then you might just adapt them to your specific domain. Versus using a model and using your data to train to do some custom training. The problem with custom training is that you have to have some data, and that is not always possible, or normally companies don't let's say don't produce this data. So you have to have some strategy to, in the long run, start acquiring data from your processes, or of course nowadays you can also generate data with LLMs, for example, but having real data is always generally a better choice. But for starting and to start, let's say, understanding the real ROI of some processes, it's okay, and I think it's a good strategy to start with these foundation models, either using an LLM API, for example, or even these smaller, let's say, foundational models on very specific tasks. For instance, nowadays, for tabular data, there are already some kind of going backwards, there are already some foundational models like times FM 2.5 in terms of time series forecasting. So it's important to really balance between experimentation, ROI, and then having a strategy into the future to acquire data and then create these smaller models very specific to some tasks where you can reduce maybe some costs and have better inference speed, so on. Also, this is a platform that maybe some of you already know, which is Hugging Face. So it's basically among other things, it's a model zoo and the data sets zoo. So you can find here a lot of models. For example, here I have selected models between up to 6 billion parameters, and it's really nice to find some new models that are coming out very specific to some tasks. For example, recently Google, for example, launched this MedGem model of 4 billion parameters. So it's very specific to this task of medical assistance to ask questions about images, and so you have a lot of these small models very specific to some tasks, and some of them are as good as bigger models, and but it can run on more let's say smaller hardware. So it's good to have this knowledge, and also you have also access to a lot of data sets that are useful to tackle specific tasks. When thinking of this world of small AI models, and it's very important to also understand that even though that sometimes these models are available, they either the weights or also the training, and you have to understand that sometimes you cannot use it for all the purposes. So there are these licenses that normally are associated with these open source slash open weights models that you have to take into consideration. So there are some models that you can't use for all the tasks. You have to read these licenses, and sometimes you even have to check some boxes to say that you are aware of this and you accept the licensing. And so it's important to have this into consideration, because not all models you can use on production, or you have to pay some fees, or it depends on the models, of course. So yeah, important to have this into consideration. Also, something that I wanted to mention is that these different formats that these models normally gain form. So uh, some years ago, already some quite years ago, it was common that different ML frameworks and AI frameworks would have different kind of would export the models in different ways, or and this would be a little bit of a mess, because there wouldn't be this kind of standard of models exchange. So nowadays, in the end, at least deep learning models are, in their essence, they are just basically a concatenation of operations. And if you have like this standard way to describe them, then you can have other systems which can optimize these operations to be more efficient for specific hardware. So this is more or less the motivation that led to the creation of this open neural network exchange standard, which is a way to basically encode how a model is described. And then these frameworks like Onix Runtime and other these ones born into the idea of optimizing these models specifically for some kind of hardware to run very efficiently. Also, regarding safe tensors, nowadays, when you go to Hugging Face, for example, or other places, normally all the files are in this format with safe tensors, because previously, normally models would be exported using the pickle formats, and the problem is that pickles can have executable code, which was like a security breach and problem. So Hugging Face themselves created this other format, which is safe tensors, which is safer. And so normally this is more or less a standard in the exchange, also models. nowadays also it's common to see other formats because these most of the times, at least these LLM models, etc., they are quantized, so there are specific formats just for this specification of the quantization of the models. So the other programs can read these files and know exactly which precision was the models trained with and prepared for. So yeah, so you have this idea. It's more now diving into AI tasks. So it's normally to create to have these pipelines of dealing with data, as we were discussing a little bit earlier. So companies deal with a lot of document ingestion processes, and we can think of, you can, let's say, categorize all these tasks in specific categories. So for example, we might want to have this task just for extracting the actual content of the document, so using some OCR to extract these tasks for the text and also the structure of the documents. And for this, we could use even, for example, a QuantVL 4 billion parameters small model. Then we might want to, from this text, exactly extract some entities and how they relate to themselves, and even ingest this into maybe a knowledge graph to have some kind of graph understanding of the entities. We might also want to have an idea of what kind of document this is, so we can even take this document and have some classification, and we can use a specific model also for this. And then normally we want to take this outputs of all these kind of models and then ingest this into either a database or other integrations that companies might have, or an ERP or a CRM, whatever it might be, or even for a RAG system where we might not now start asking questions about these documents. Nowadays, for example, Docling is a popular, let's say, framework for creating these kind of pipelines, where each piece of this pipeline is more or less like a legal block, where you can, it's basically consists of modular AI models where you can plug and play different ones, and they have more or less standardized the outputs format. So you can take any kind of document, and in the end you can have this markdown format or HTML, JSON, or even their specific document type, which are doc tags. And they integrate with a lot of other toolings, such as LangChain, QNI. You also have MCP server integrations. And this is great for a lot of tasks. And I have listed here some kind of the tasks that are normally used with. So for creating this retrieval and general assistance tasks where you might want to ask questions about these documents, for agentic workflows, and even just for knowledge extraction. And as you can see in this AI-powered pipeline, so you can change this with different models, just for example, to extract the text from the documents, or to even understand the layout of the document. You can use different models for that. So this is visually just an example of tasks that is normally common, which is taking, for example, an invoice and using a vision language model, for example, to exactly extract what's present in the documents. Nowadays, these smaller, for example, QuantVL models, they are quite good with these tasks. Of course, it depends on the richness of the document. So some more complex documents with a lot of pages, it might not deal very well with currently, but I think it's a matter of time. So recently, as I was saying, for example, Dypsis launched this new model. They have really good benchmarks. I haven't tested them yet, but supposedly they compete with the Gemini's proprietary models. So we might be getting there with smaller models. So we also have, as I was saying, this liner 2, for example, encoded model. It takes to 200 million parameters, so it's quite small and you can run on a CPU very easily. And you can use it for very different tasks, such as entity extraction or classification, or even just, let's say, general JSON extraction by providing some kind of schema of what you want to extract. So it's very powerful, and there are a lot of tasks and company processes where this makes sense to use. And we can already start using these smaller models. We don't have to use let's say, send our data to these proprietary APIs to extract some tasks. And this liner 2 is a good example of that. Now I'm providing some other kind of tasks that are normally popular. So of course, text generation, which normally are used in chatbots, and now it's common to have like this other tasks like object detection, where, for instance, YOLO 26 and Deter, like I was saying previously, just came out, and they provide very good quality results, and they are quite small. We have other tasks like segmentation, where you want to to find elements in the specific masks for the elements in a picture. You have this task of document analysis and extraction, also vision language when you want to ask some kind of questions to an image. And for this, normally Quant3 VL models are quite good as well. Also, different tasks like speech recognition, text-to-speech. A lot of these, there are a lot of small models that are very good at tackling this. Even for semantic search, for some many years now, this can be done with small models. You don't have to use any APIs for this unless you really need some very quick latency results. Also for forecasting and tabular prediction, even for anomaly detection. There are a lot of small models and ML models that can tackle this quite well. And then these more classical problems of classification, regression, even clustering, you don't need big models for this, and you can use just XGBoost for many of these problems. And normally let's say the problem with this normally is more tackling with working with the data and making sure the training or inference is efficient and you are using the right features. And this brings us to also this question and problem of when to use classical machine learning versus deep learning. So it normally depends on whether you have data or not, a lot of it, or you have low data. Also, whether data is more structured in tabular way, or you want results to be some kind of interpretable, because deep learning normally is considered like a black box, so you don't really you can mimic some kind of explainability, but in the end, it's really hard to know what happens behind the hood. And also, normally deep learning is associated with expensive models, which normally require some kind of GPU to be efficient, and whether classical models normally work quite well on CPU devices. So it's you have to balance exactly the needs in terms of speed, data that you have, and to understand also and the category of problems, to understand which let's say family of models works best for these situations. Regarding in the world more of vision language models and language models, you have also these frameworks, which is Antslof and Xlotl, which are quite good frameworks for fine-tuning with very few parameters, and they are very efficient. to adapt to a specific domain where you might need to make some very specific training. These libraries are quite good and efficient, and they also have quantization, so you can have these very efficient models. So they are very nice to have in mind if you need to do some fine tuning. Regarding generally more related to training of these models, you also have PyTorch, which is more generally used for deep learning, scikit-learn, which is more general to machine learning, and you also have Hugging Face, because Hugging Face more or less began as a library for transformers, so it also have a lot of tooling to train models, and they have evolved a lot from when they start. So, and this brings us to this topic of what optimizations are normally done in these fields and deployment strategies. So it's quite common for these models to be quantized. So what is this exactly? So back some years ago, models normally were trained on floating points with 16 bits per meter, or even 42. Nowadays, they usually start with much lower bits per weight per meter. So normally nowadays it's more like 16. If you want to reduce to a smaller precision, normally that's what quantization means. You do some post training, or you do some training to make this this mapping of higher precision to lower precision. Even the hardware of the GPUs evolved to have this this architecture in mind of using lower precision, because at the beginning the kernels, the actual architecture was expected a lot more precision. Nowadays they have specific hardware for running with lower precision. So the hardware itself also is what is providing this quantization also to have having more impact. When you are quantization, you have to have in mind that you are also losing some kind of accuracy of quality. So it's important to have to find like the sweet spot. For example, before I was talking about the ML format. So one model format that is common is this GGOOF. Normally, when you find, let's say, any LLM model or machine learning model, normally the file name normally gives you some information about the model, so the number of parameters, and these GGOOF files normally also by the file name provide you some kind of information about what quantization precision was used, and what kind of method was used to produce this quantization. So, for example, this one would mean that it was quantized with 4 bits using the K algorithm, with the median variant. And it's important to find like a sweet spot, because if you go to a very low precision, you start losing a lot of quality. So normally it's good to stay between K4 and K8 to have to still have some good quality. Of course, when you are reducing the number of bits, you are reducing the size of the model, so it runs faster. So it's yeah, it's a way you have to trade off some this precision by the speed, and finding the sweet spot is important. Another optimization that normally is done is this theme of knowledge distillation, which is basically you take a bigger model, let's say, and you have this smaller model, and you try to use let's say the intelligence of the bigger model to teach the smaller model. Classically, this means that you train one by side to the other, and you approximate the probabilities of one to the other. Nowadays, at least in the LLMs, normally what is done is a little bit different. It's more like it's called like strong to weak distillation, where you take the outputs of a bigger model and you teach the smaller one to produce the same output based on the same input. So, but the main idea remains the same. Nowadays, no one really runs like an LLM, at least in production, without using an inference engine. So you have the model, but then you want to run it with you want it to be very efficient. So you want to take batching, you want to make good use of the KV cache, and for that you would use some kind of inference engine, like I have this here on your right side. So Olame is very basic, and it's normally more interesting for just doing some tests locally or just to test some models locally. But for really production use cases, you want to use either one of these, so VLM or SGLang or Max, which are really optimized for for having these language models, visual language models, embedding models, wherever you can think of, with very efficient speed. And if you want to even scale it a little bit, you have these libraries like Ray or GPU Stack. GPU Stack is a very nice library. If you have like a collection of GPUs and you want to run them fast, under the hood, the GPU Stack uses the backends like SGLang or VLLM, and you have a nice interface. You can set up everything visually, and it works very well. You have control of all the of all your GPU instances, and you can even partition the instances and make the best use of your GPUs to run these models efficiently. So more holistically, talking about the pipeline, so taking all of what I was telling you into consideration. So normally the first step is to, let's say, export the model into some kind of standard. Then you might optimize it for bigger speeds. So you might want to really optimize the operations. So creating some kernels to make them really fast, either by fusioning some operations. There are a lot of techniques for this. You might really want to quantize them, but also to run at bigger speeds, so reducing the precision of the parameters. And then you have this deployment where you might take use of these these inference engines to really run to speed concerning the hardware and some other logics related with other specifications, like I was telling you before, with the VLLM and the SGLang. So yeah, it's common more or less with, for example, with computer vision models. It's very common to use like this once runtime, which allows you some accelerations on specific hardwares. You have older ones, like more specific to Intel architectures. You have OpenVINO. And for example, I didn't mention, but you have also like this pruning mechanism, which is more related with removing. So in deep learning, you have a lot of parameters. So if you think of 8 billion parameters, maybe there are some parameters that are not actually providing value to the model. So this idea of pruning is trying to remove these redundant parameters, which might not be providing value. And this also speeds up because you are reducing the number of parameters. Regarding also related to this deployment, you have to think of other these criteria. So normally it's important to create you have your models in a container, because it's easier to monitor things and to move it around in different infrastructures. You have to have specific model serving. So for more related with, let's say, PyTorch models or machine learning models, you might want to run them on these libraries like Torch Serve or Tweet and Inference to gain the speeds in, and to don't reinvent the wheel on how to create these APIs for inference. Then you might auto scale if you want. You might use some Kubernetes to scale the, let's say, the infrastructure that you might need. And very importantly, you have this stage of observability. So it's very important to to capture some specific metrics. So either related to the resources you are using, the latency of the requests, and how many requests you can make per second, so the throughput, but also related to the models, how the models are behaving through time. So the the precision of the model might be reducing or not. The quality of the answers might be might be getting worse. So you have to really capture these metrics so you are aware whether you have to make some adjustments. Sometimes the problems you don't even control. Imagine that you have some camera where you are receiving input and the camera has some problems. But it's important to have these metrics to understand that whether the issue is related with the model, the inputs, or the sensor that is capturing the data. So it's really important to capture these metrics and to use the tooling which is normally used. So, for example, using Prometheus and Grafana for a dashboard so you have let's say an UI to understand what is going on. For LLMs, normally LangFuse is also quite a popular library for this to either control costs, understand the reasoning of an agent, how it's behaving. So it's very powerful, and so it's very important to really keep track of these metrics and understand how your models and your deployments are going into the future. Regarding deployments, it's also very important in this realm of machine learning operations to think about what kind of strategy you might use when deploying the model, because you might have let's say, a version that is currently online. You might have understood that something was wrong, or you just want to improve because you found out that better architecture would work best, and you evaluated, and you want to make some changes to the current version. So you might want to use this canary deployment where you start with a very small set of users, and gradually you can augment it to a bigger user base. You can use like a load balancer to start diverting the model, the users to a specific model. You can use A/B testing to make tests. So for some users, you provide the model for some users and see what model gives best results. You have also this shadow launch where the older deployment remains the same, but you use the new model to also receive the inputs, but you just log the outputs to understand, for instance, how the model you created is behaving in comparison with the old one. You can also use feature flags. So in a more general sense, you can just control it by using feature flags to when to deploy and what users to deploy this model to. So there are a lot of techniques. It depends on the use cases, also on how the models are deployed, because bigger models maybe require more infrastructure or more costs. So you might want to select different approaches depending on the requirements and constraints. So concluding a little bit about what I talked about. So it's very common nowadays to see these hybrid architectures, which more or less mixture these state space models like Mamba with transformer architecture. Mixture of experts architectures are also quite common nowadays because they balance really well quality with speed by using a little bit more memory, GPU memory. And it's this notion of foundational models is really growing. So for very specific tasks, we are starting to see these baseline models, which are a good balance between, let's say, quality and speed, let's say. What I expect to see in the futures, even nowadays, is that local models will start gaining even more importance. They will start getting better, so we will start having more capabilities with smaller models. We will have much more specific models to specific tasks, and yeah, that's what I'm expecting for this for the future. If you want to start with whether in your company or this roadmap to start seeing the value of AI and small models, I guess you can start with identifying a very specific use case for where I provided a lot of examples where maybe this AI might help you in these specific tasks. You can try one of these models, which are smaller, like the Liner 2, which can easily run on your computers, or even a QuantVL, a smaller one, and do some tests to understand if, even if you had a bigger GPU or a bigger model, if the ROI is relevant, justifies the investment. You can even make some integrations, either with some systems that you have in your organization, like ERP, CRM, and do some tests. And then you can scale it if you find that it can actually bring results. You can have a strategy to scale it and to create some kind of service to deploy this creation that you have. Easily, one way to start all this is just by installing, for example, Llama. You can start running these local models very easily. These models normally are available. So you can, if you pick a task, you can start really, even visually, start making some tests to see if there is if it can help you. And in that, it's important, always important to measure the success. So taking these metrics, as I was saying previously, and you create a report and you can scale it from there. Some places to start. So I'm provided here some links. So for example, Hugging Face has a lot of models. Normally they have a good documentation to get things running. You also have the website from Llama and all the other inference engines that I was mentioning. You have some key papers that have been coming out. And for example, to start using Llama is very simple. You can just either go to the website, but it's basically 2 lines in the command line, and you can start playing with it. Normally, these models run on almost computers. It depends, of course, on your laptop, but if you have enough memory, you can run them. So what are the limitations yet? More related with small language models. So they are not, it's very important when you start reducing the number of parameters to understand that these are not, you cannot expect them to have a very general knowledge. So you can, it's very important, but I think that generally about language models as a whole. So I don't look at them as a library of knowledge. So they normally are very good at, according to the context that they are aware, to understand the relationship and kind of reason a bit about the context. So if you provide a good context to these models, they are very good to extract the information that is there present. And with the intelligent prompting, you can actually use this for a lot of interesting tasks. So so for RAG, of course, and but don't expect it to actually answer you questions that are not in the context, because for me that's just that's not really a smart move, because you are expecting a lot of these models which will not work very well. So yeah, so basically that's one of the biggest limitations. And to really conclude, the key takeaways is that choose the right model size for the task, and find the specific models that are quite small but have already been trained for your tasks. For example, if you go to Hugging Face, you have a specific task, see what models already are available, check if you might have to do some fine tuning or to do some specific training to adapt to the domain, because sometimes you have to do a little bit of adaptation. But in the end, normally the out of the box, most models already provide quite good value. So it's a good way to start using these models. One domain which, and that's why I started basically the presentation with this, is document processing. So there are a lot of key cases and a lot of use cases related to this, and it's the one where you can maybe more easily find some use cases to use these smaller models. And here, I mean, deployment, this is a little bit of a catchy phrase, but nowadays these small models can really run on some laptops, and so and it will, as I was saying, into the future be even more real. So these language models will start running on more modest devices, and I guess that's the future. And to conclude, so just to talk a little bit about what we do here at Dypsis. So we are a boutique company specializing in artificial intelligence, and so we help companies with creating these roadmaps to help them find good use cases of AI to implement them. We create these pilots to start for these companies to start releasing some value with these AI approaches, and we also provide end-to-end solutions where we help these companies integrate with their systems and have really, let's say, products and working solution for their specific use case. And finally, we also provide some training. So this webinars is a little bit related with this idea. So we have some specific courses and learning pathways to help companies gain more knowledge, either in general AI and in specific, more specific cases. So we have these different learning pathways, more related to developers, and then more to business leaders. And of course, we also offer some custom training. And that's it. I don't know if you have questions, or if you want to discuss something in more detail. I'm open to it.
No questions so far.
So you can use the Q&As if you have any question. If not, maybe we can stop the webinar.
Yep, there is no questions then. So thank you everyone for coming. I hope it was interesting and you have learned something today. And yeah, thank you everyone.
Thank you. Have a nice day.